So what I'm looking for are the things that are really going to enable whole new classes of missions, things that are really going to enable new ways of doing business. And so problem number one for us, especially in human, is making things affordable. If we can't afford to go and afford to do the mission, it's not going to happen. The second thing is to remember that the reason we do human exploration is to enable the science. And so when we do these missions to the Mars surface and things like that, we really have to protect and focus on the science value that we're going to achieve while we're there. You have to look up from time to time and look at the system level and make sure that the thing that you're working on, the component that's being developed, is actually going to have an impact at the system and the mission level. So let me talk about one of the first things that we want to get right to achieve these, in situ resource utilization. If we can't make oxygen from Mars, we are not going to send a human mission to Mars. We cannot send the 25 metric tons of oxygen required for that ascent vehicle propulsion without ISRU. The next problem, once we figure out how to deal with propulsion, is life support systems. We have a lot of technologies maturing in life support systems. I think that even if you have in situ resource utilization to produce oxygen and produce water, you're still going to need closed loop life support. If you have an open loop system of water and oxygen coming in, then you have an open loop system of human waste coming out. And I think that's probably bad for trying to conduct any sort of search for life on the surface of Mars. The next big mass problem and logistics problem for making these missions affordable is food. Food is part of this Earth-independent chain that we really have not been able to break satisfactorily. We have to find ways to make them even more affordable than the shipped food that we have now. It's going to be a pretty significant change in the way we do business compared to the EVA spacesuits and operations of today. Our gloves right now cause damage to our crew members in their training operations when they use them a lot. Between the smashing of your fingers into it and the damp environment, their fingernails fall off. If you have to do EVAs 3 times a week for the next 2 years, that's not acceptable. But these changes need to roll through the whole system. We need new materials, really. They're going to be able to cut beyond the back mass for the suit and the portable life support system dramatically once we're back in a gravity field. Cutting the weight down for the joints, all of those things, surviving the dusty environment, not needing maintenance for years and years, are pretty big challenges. We still have a ways to go in transforming the spacesuits we use today into the thing that's really going to let us do the Mars missions of the future. For most of the human life support system problems, we want to use the space station as our proving ground. We want real human beings in real microgravity operating full-size systems for several years until we're going to trust them enough to use them to go to Mars. We want to get out there, we want to explore. Human operations, as much as any other part of NASA, is trying to get science done.